rock star genealogist, I think, is part of the press release you sent to me, which went out in the last Gazette we put out last month. You certainly are a busy man, and it's great to have you here tonight. So, with that, Maurice, please.
Thanks very much, Tony. Thank you, everyone. A great big thank you to the Genealogical Society of Ireland for inviting me here to speak this evening, and it's great to see so many familiar faces in the audience. So I very much appreciate you all being here on this wonderful summer's evening when you could be at home cutting the grass. So you know it needs to be done. So what I'm going to talk about today is really DNA and Irish genealogy. Where are we now and where are we going to? So it's a little bit of a look at where we've come from and a little bit of a look at where we might be in the next 5 or 10 years, because I think there's been some really interesting advances in the science over the course of the last several weeks. And I'll be talking a little bit about those events and how they have implications for us going forward. Now, as my role as Education Ambassador for the International Society of Genetic Genealogy, part of my task is to take relatively complex topics and make them into digestible, bite-sized chunks for the average member of the public. So that's very, very much a part of my role as Education Ambassador. And what I'm going to do during the course of this presentation is touch on a lot of things, a lot of activities and events that we are doing within Ireland that is advancing the science of genetic genealogy. So there are various genetic companies that you could do the DNA test with, and I'm sure many people here have tested with some of these companies. It started off in 2003 with Family Tree DNA and the Genographic Project, and then later on 23andMe joined the foray, and then Ancestry DNA, and then there was a company called Britain's DNA, which also had an offshoot, Ireland's DNA and Scotland's DNA, but that is now defunct. And in its place, we have companies like Living DNA, which has been around for about 3 years or so, and MyHeritage DNA. So the face of genetic genealogy is changing, and there are 3 main types of DNA test. I'm just going to come out of there and go into this here, so I can. Where has it gone now? Because it's actually playing things that I don't want it to play. Slideshow, and we don't want that. So I have to untick those and then go back there. So yeah, so there we go. So there are 3 main types of DNA. The YDNA goes back along the father line. The mitochondrial DNA goes on the other side of the family tree, back along the mother line. And the autosomal DNA is the test that covers all of your ancestral lines, but it has a limited reach of about 5, 6, or 7 generations. So that will take you back roughly to a connection with cousins with whom you share a common ancestor within the last 250 years or so. So going back to about 1750, 1700. So that's the most useful test from a genealogical point of view. The YDNA test and the mitochondrial DNA test are good for recent ancestry, but also deep ancestry, going all the way back to genetic Adam and genetic Eve 250,000 years ago in Africa with the appearance of the first anatomically modern humans. And because of the reach of YDNA and mitochondrial DNA, they've been very, very useful for human migration studies and studies about how human beings have populated the planet. But of course, they're not particularly relevant for genealogy, which for us means going back into the 1800s, 1700s, and maybe even a little bit further if we're lucky enough. Now, this is a screenshot of my YDNA results, and this is what you see with all of the tests. You have a list of matches here, and then here you have the most distant known ancestor. Oops, I can blow it up a little bit there just to show you that this particular one down here says Thomas Gleason, 1822 to 1887, Boherlahan, Killamackill, and that's in Tipperary. That's the single most important piece of information that you can supply if you're doing a YDNA test, because the conglomeration of all of these in a surname project will help identify where the genetic group to which you belong came from originally. I'll show you a couple of slides in that regard. There are over 9, now on its own, your results on its own don't tell you a huge amount. It might tell you people that you are closely related to on that particular father line, but when you join a surname project, that's when you really get the most out of your YDNA results, and there's over 9,400 of them on family tree DNA. And of course, a lot of these surname projects are to do with Irish surnames, because the people from Ireland went and populated the whole planet, and we now have an 80 million strong diaspora all over the world, 40 million of that in the US. And a lot of people in these surname projects will be US based, because that's where these databases started off in the first place. And currently there's about 608,000 YDNA records in the family tree DNA database. Now, I run the Gleason DNA project with my co-administrator Judy Klassen, and in this project we have a display of all the members' results in this fashion. And the most important thing about this very busy slide is the pretty colours. And the reason why those pretty colours are so important is because you see a pattern, and that pattern is a genetic pattern. So imagine that these are all the members here. Imagine that their Y chromosomes are all stacked on each other, and all along the Y chromosome you have these markers. These are the marker names up here, and they're all lined up in a row, and the various values for each marker are in these columns here. And you can see that there's a kind of a column that stands out there, another column that goes all the way across this particular group here, another one here, another one here. That's lineage 1. This one is lineage 2, and you can see that the coloured pattern is completely different. And that we also have a third lineage, lineage 3, and again you see that the coloured pattern, the genetic signature, is very different compared to lineage 1 and lineage 2. So it's this similarity of the genetic profiles that allows us to group people together. If you match the genetic profile of lineage 2, I can say with 99% confidence that your Gleason ancestors came from North Tipperary, because a lot of the members in lineage 2 have recorded their most distant known ancestor as coming from Tipperary. If you match the genetic profile of lineage 3, I can say with 99% confidence that your Gleason ancestors came from West Clare. And if you match lineage 1, I can say they came from Cockfield, Suffolk, in England. And not only that, your most distant ancestor is probably Thomas Gleason, who was born there in 1609. And the people in lineage 1 are New England American people. And this just goes to show the kind of population explosion, the founder effect you get when a single immigrant comes in to America and he has lots of descendants who have lots of descendants. So anybody in lineage 1 can go back not just to a specific place of origin, but a named ancestor. And that's an incredible power of DNA to do that. Now, there's other groups within the project. This is a US group. We're not sure where they came from. And then there's a group of ungrouped people, and you can see that this is a hodgepodge of different colours. There's no specific genetic signature in these people who have not been grouped as yet. They don't have another genetic match in the project at this point. So that's the Gleason DNA project, and this is exemplary of other DNA surname projects. These can help group people together, firstly. Then the DNA can identify a person's origin, and it can even help identify a person's ancestor. So that's the power of DNA. And of course, over the course of the last 15 years, these surname projects have matured, and a lot of them now are at the level where we are able to write up the findings, and they are linked. A lot of the genetic groups are linked to specific ancestral places, and even in some cases, like in lineage 1, it can go back to a named individual. So doing a YDNA test and having these kind of matches almost gives you your genealogy served to you on a platter. It certainly tells you where to look and where to continue your documentary research. Like I said, it also helps us with the study of population migration movements. And we've also been able to put together the tree of mankind, starting with genetic Adam and dividing the tree into the various branches that split away. And that's by studying these minor mutations that occur in the DNA every couple of 100 years. And then over the course of many, many millennia, we find that we're able to generate this tree of mankind. This is an example of how many the branches there were just in haplogroup R, which is the most common genetic group within Western Europe. And from 2002 up until the present day, the number of branches has increased so that now we have more than 5,000 sub-branches below haplogroup R. And that is just getting bigger and bigger and bigger. And the more people that actually join the various surname projects, the tree of mankind is now coming down sufficiently far downstream that is actually going into the surname projects themselves. And we're actually seeing sub-branches within surname projects. So for example, in the Gleason DNA project, I'm lucky enough to have a sufficient number of people in lineage 2, the North Tipperary Gleasons, that I've been able to date the beginning of this genetic group to roughly about 1,000 years ago, which is about the time that surnames started in Ireland. So I've been lucky enough to date that, and now there are sub-branches coming down, so there are about 11 major branches of Gleasons within that North Tipperary group. And each of those branches goes down to perhaps a particular townland. Some of them went off to, the oldest pedigree we have goes back to 1600. And that was from somebody who was an indentured servant and ended up going over to the US. And the surname there changed from Gleason to Clesson, C-L-E-S-S-O-N. And you wouldn't have thought, just by looking at the surnames, that these two could possibly be related. But when the DNA came back, he was an exact match to one of the most ancient branches within our group. So it's very, very interesting the way that this is evolving. And over time, what's going to happen is that certain DNA markers will become associated with certain locations. And those locations will be associated with certain surnames. And those surnames may very well tie in to the ancient genealogies, just like we have in Leabhar Morna and Éilech, and what other ones? O'Farrell's Linea Antiqua. Bartiaski has done some great tables of all the medieval lineages, and of course we have O'Hart's The Origin and Stem of the Irish Nation. So it's very, very interesting time that we're entering into now, because as the surname projects mature, we're getting more information that perhaps ties us in to these ancient Irish genealogies. So that's a very exciting place to be, and I think over the course of time now we'll see more and more of these Irish septs and clans being associated with a specific genetic signature. We've identified the genetic signature for Brian Boru, and we've identified the signature for Niall of the Nine Hostages. Whether he was mythical or not, we do have a signature for the O'Neills, the E. Neil. Turning to autosomal DNA, which is the most popular of the DNA tests, it can tell us about our ethnic makeup. It can put us in touch with genetic cousins. It can tell us a little bit about our medical risk. If you test with 23andMe, that's the only company that does that. And it can tell us what percentage of our DNA is Neanderthal DNA. Because back in the day, we interbred with the Neanderthals going back 40, 50,000 years ago, and we actually carry some of their DNA within our genome today. As far as ethnic makeup is concerned, it used to be a case where it could just tell you 10% of your DNA is from Europe, 20% of it is from Asia, and 70% of it is from Africa. So it was just on a continental level. But then as more people joined the databases, as the algorithms for calculating ethnic makeup were improved, it became possible to just do it on a sub-regional level within a continent, and then even down onto a country level. And now we're at a sub-country level. So you see, this is my genetic makeup on Ancestry, and they have a feature called Genetic Communities, which was introduced in March of last year, which is just over a year ago. And you can see that I have a big swathe of DNA from Southern Ireland and another swathe of DNA from the North Midlands. So this is going to become more and more precise, and it will drill down onto a much more granular level as we do more analysis of the DNA that's coming in. Living DNA, for example, have used the data from the People of the British Isles project, and this is the type of division that they get geographically and genetically, and they're planning to do the same kind of thing in Ireland, so that we're going to get something like this, that the different areas of Ireland will be genetically mapped. So you'll be able to do a DNA test, and on the basis of that DNA test, they'll be able to analyze it and say 10% of your DNA comes from the Cork Kerry or Southwest Ireland area, 20% comes from the Northeast Ireland area, and about 50% of your DNA comes from Mayo and another 10% from Galway. So that's the kind of thing that they are aiming to provide, and that will happen in the next couple of years. And of course we know this is possible because of the great work done by the Genealogical Society of Ireland in collaboration with the Royal College of Surgeons, and of course that was the Irish DNA Atlas project, and our good friend Ed Gilbert has presented here previously on the project, and he's also talked for the last 3 years at Genetic Genealogy Ireland in the RDS every October. And the results were published this year in one of the Nature journals, and you can see that this is the type of pattern we're getting for autosomal DNA within Ireland. And it's defining some very distinct genetic groups which are geographically circumscribed. So we're seeing a little bit of influence of the plantation of Ulster. We're seeing some divisions that perhaps correspond to some of the ancient Irish clans and the territories that they moved in. So this is very, very exciting, and it's something that will continue because we're still recruiting for that project, and it will continue for the next couple of years. And congratulations to Seamus and the team for such a great job. In fact, let's give them a round of applause. When you go into your results, whether it's on Ancestry or 23andMe or Family Tree DNA, it's very user-friendly. You get a list of your matches. Here you can see that I've got a first cousin match, a second, several third cousin matches, and then you just click on the View Match, and it comes up with this type of diagram which shows you their family tree. It shows you can click on Shared Matches to see what matches you have in common with each other. If you click on the little I button up there, it tells you the amount of DNA that you share with that particular individual. The same sort of thing with 23andMe. Again, these are the list of matches. These are the people that I match. Some of them are third to fourth. These are all third to fourth cousins. These are third to fifth cousins. And you can send them a message. And basically, it's all about collaboration. You just have to say, I see you and me, we are match on our DNA. Would you like to swap pedigrees and family tree information and see where we connect? Same thing on Family Tree DNA. These are a list of my matches here. This is the total amount of DNA that I share with them in centimorgans, and I can click on the email button over there, and that puts me in touch with them, and we can collaborate on trying to figure out how we are connected genetically. There's also this public database, JED Match, and this is where you can download your DNA data from whatever company you've tested with, and you can upload it to this public database, which allows people from different companies to compare their DNA with each other. Because obviously the different companies don't have access to other companies' database. They don't talk to each other. You have Ancestry doesn't share its information with Family Tree DNA or with 23andMe. So a couple of volunteers from the genetic genealogy community set up this database so that people could upload their data to the database for comparison between companies. And we'll be talking a little bit about that later on, because there's currently 800,000 profiles in that database, and it has become an unusually powerful tool in ways that we might not have imagined a few months ago, but a couple of weeks ago, several things happened that have made us kind of sit up and take notice, and I'll be talking about those. The secrets of success as far as DNA is concerned is to have an online tree, if at all possible, to collaborate one-to-one initially, and then maybe in small groups. And remember that DNA is just a pointer. All it's saying is that you and you're related to each other, now go away and find out how. And then you have to go back to the documentary records to see if you can find common locations, common surnames, and eventually a common individual in your respective trees. So you don't have to be technical with DNA. You don't have to get involved with the technicalities of DNA to actually make it work for you, because it's just a pointer, and at the end of the day, you just have to swap pedigrees. So if someone says to me, oh, hi, Morris, I see we're a DNA match, it's on chromosome 12, from this, I said, hold on, I don't need to know the technicalities. Here's my pedigree. Do you notice any common locations, common surnames, common individuals? Because if you do, let's chat. If you don't, thanks very much for getting in touch with me, and the best of luck with your genealogical research, because we are back to square one. There's nothing we can do. We could try to collaborate in a small group to see if a group of us match each other, and we both all share the same DNA, then maybe as a group we could do that. But if it's just one-to-one, you can't do anything more if you can't identify any common locations, individuals, surnames or individuals. One of the things that you can start doing when you work in groups, and it can be just a group of 3 people, is triangulation. And triangulation has been around for a long time. You can see here the definition in Wikipedia. It's been used in trigonometry and geometry for centuries. And all it means is you have people, like these people here, in modern times, that's us, looking back at a distant point, that's your great-great-great-grandfather. So that's all triangulation is. It's looking back into the past from the present and trying to triangulate on a specific distant ancestor. Now, I did this inadvertently in my own family tree. So this is me here. These are my siblings. There's my dad. And if you go back along one of his ancestral lines, back up to his great-great-grandparents Patrick Spearin and Mary Morgan, I found that I had, without planning it, I had tested 3 of his cousins, all of whom are descended from the same ancestral couple. So all of them had DNA passed down to them from Patrick Spearin and Mary Morgan. So this got me thinking, and I thought, any people, any matches that they share in common with each other could very well have had the DNA got DNA from the same origin that above Patrick Spearin and Mary Morgan that passed the DNA down to these 4 cousins here. So what I did was I compared A with B, A with C, A with D, B with C, B with D, C with D, and I put together a list of 100 shared matches who could have received the same DNA from the ancestors of either Patrick Spearin or Mary Morgan. We can't tell at this stage whether it was on the Spearin side or the Morgan side of the family. But, to cut a long story short, after 2 years and writing 100 emails to people, somebody sent me the notebooks of Professor Waddell, Professor of Military History, Trinity College Dublin, in the 1910s, who had done a study of the Morgan family and had gone into the Public Record Office and used all those wills and all those primary sources that went up in flames in 1922 and had written about it in his notebooks. And there were my great-great-grandparents, Patrick Spearin and Mary Morgan, and he also gave me the place of birth of my great-great-grandfather, Patrick Spearin, which I never knew of before. But not only that, the Morgans actually came from a very well-to-do family. And he gave me 5 generations of Morgans going back to Limerick in the 1600s. But not only that, there was a link to the Morgans of Tredegar House in Wales. And they were a rowdy bunch, and they got into a hell of a lot of trouble over time. And they had a lot of money, and they spent it. And I am related also to this chap here, who was Sir Henry Morgan, Governor of Jamaica. I'm also related to this chap here. Any ideas? JP Morgan. And I'm also related to this person here. There's her Morgan ancestors, and it comes down via her mother's side. So that was a huge surprise. You know, I am apparently, and I do have to check the sources, but I am apparently the 11th cousin of Princess Diana, which made me joke, you know, see you at the wedding in May. And I was at the Irish Georgian Society St. Patrick's Day party in London, and I was telling this story to the lady I was sitting beside, and she said, oh, that's a coincidence because I have a +1. So I almost got invited. She said, oh, but you're traveling in Australia, so you can't come. So I almost got invited. I could have seen Ed Sheeran live. So you never know what DNA is going to open up for you. And never in my wildest dreams would I have thought that I would have gone back to Wales in the 1600s and then down to Captain Morgan, JP Morgan and Princess Diana. So it's opened up a whole new avenue of research for me, and it's going to keep me busy for a long time. So that's one of my retirement projects now, one of my many retirement projects. Within Ireland itself, we have actually come a long way since 2003. We have set up our own Ireland branch of the International Society of Genetic Genealogy, and we have a Wikipedia page that summarizes Irish DNA projects, autosomal DNA projects as well. It lists project administrators working within Ireland. It also has an account of some special interest groups, talks about Genetic Genealogy Ireland, and a variety of other things, including the various meetings going on around Ireland during the course of the year. We've also included a commentary on the adoption bill and help for Irish adoptees wanting to use DNA. So whereas we started off working one-to-one, we've now developing into the situation now where there is actually a group of people who are working towards similar goals. Genetic Genealogy Ireland started in September 2013. These were the 3 days of DNA lectures that we'd have in the RDS at Back to Our Past, and they've become very, very successful. In fact, currently, we've put all of the videos up on YouTube. We have a YouTube channel, and these are all free to access, so it's a service to the community. And currently, up to the 6th of May, there have been 200,000 views of these videos for 2.2 million minutes watched. And if you were to do that on your own, it would take you 4 years and 69 days. So that's pretty impressive. The audience, you can see, is largely American. 60% from the US, 7.6% from Canada, 11% in the UK, 7.5% in Ireland, and 5.2% in Australia. But this is a wonderful way of illustrating how we are reaching the Irish diaspora. And it's a great way of pulling them in, and a lot of people are actually travelling over from America to specifically go to the DNA lectures at the RDS, it's really a piggyback conference, because Back to Our Past was already organised, and Family Tree DNA were very kind to sponsor a lecture area where we could give lectures about DNA and genealogy. So that's proved very, very successful. We also did a 27-page commentary on the adoption bill last year, and met with the Department of Child and Youth Affairs just to impress upon them how DNA was going to revolutionise the way that adoptees approach searching and tracing for their birth families. And they were very receptive to that. We also have a help area for Irish adoptees wanting to use DNA, and last year we trained 45 social workers who work with adoption agencies all over Ireland in what DNA is and how it can be used to help adoptees. And more now we're actually being referred adoptees who want to use the DNA route to try and find their birth families. So that's a development that we wouldn't have foreseen perhaps a few years ago, but now the adoption agencies within Ireland are actually referring clients to us for this type of work. In terms of where the future is going with autosomal DNA, I think autosomal DNA projects are going to become hugely important. I was down in Mount Bellew at the weekend. There was a Genetic Genealogy conference there, and Martin Curley, who organised it, also helped organise the commemoration activities for 33 young women who left Mount Bellew Workhouse in 1852 on a bride ship to Australia. It took them 5 months to get there. They thought the ship had been lost, and then finally 2 months late it turned up, and they got married in Australia. All they left Ireland with was the Hurley chest, which had 2 pairs of shoes, 2 dresses, several petticoats, and that was their future in Australia. And the descendants of some of those women came back to Mount Bellew at the weekend for a very emotional commemoration, and now there are thousands of descendants of these women in Australia today. So it was very, very moving to hear some of the accounts. Kieran Cannon, the Minister for the Diaspora, gave a very impassioned speech on how important it is to connect with the diaspora. He himself has done his DNA testing, and very proudly comes back as primarily Connacht genetically, which you'd probably worry about if he didn't. And he was a great proponent for DNA testing. But this is where I think it's going to go, is that we're going to have much more of these autosomal DNA projects, where people join the project, and we'll have networks of connected people who are connected by autosomal DNA. Currently, we have various projects in these places here, but a large swathe of the country still remains to be covered. And so there is a wonderful opportunity now for any budding project administrators in the audience or listening on YouTube to actually take on local projects where we can create these autosomal DNA networks. And that's connecting the people within the locality in ways that they had not imagined previously. Irish academia has also been involved in a lot of advances recently. We have the Irish DNA Atlas project, which was a seminal project, very similar to POBI in the UK, and the two of them have pooled the resources to produce some of the wonderful maps that you see in those publications in Nature. But we also have had some great work done at the Ancient Labs in Trinity College Dublin and in University College Dublin. And one of these was the discovery of bones under a pub on Rathlin Island. And the amazing thing was they still were holding their pints and they hadn't spilt a drop. But this changed the way that we actually thought about the populating of our country. And this work was undertaken by Professor Dan Bradley of Trinity College Dublin. There's the paper there. But he used whole genome sequencing, which was a novel and revolutionary way of analysing the DNA. Because the tests that we do, they test about 700,000 DNA markers on our autosomal DNA. But the test that Dan has done tests 3 billion markers on the entirety of the DNA. So it's an order of magnitude more granular than the test that we do. And that caused a minor revolution. One of his colleagues over in Harvard, Professor David Reich, is actually developing a method that may even be cheaper than the forensic methods that are used to do this similar type of test. So that's a great way of introducing the future in terms of ancient DNA. It is rapidly advancing, and keep your eyes on this spot because more is to come. And so far they've only published the results of 4 of these ancient skeletons dating from 4,000 to 6,000 years ago. There are approximately another 20 to 40 skeletons yet to be analysed. So it's going to tell us a huge amount about ancient Ireland 4,000 to 6,000 years ago. Another very interesting project that was done for the 1916 commemorations was the identification of Thomas Kent. And this was done by the lab at University College Dublin. Jens Carlsen was the person that spearheaded it. He presented the results at Genetic Genealogy Ireland, and you can view them on the Genetic Genealogy Ireland YouTube channel. But the techniques that they used for the identification of Thomas Kent were innovatory. These were this was the first time that such techniques had been used, and it will change the way that people approach this type of identification, because they also used whole genome sequencing, which was not something that is generally done in forensic situations. But this just goes to show that between Trinity and UCD, Ireland is in many ways leading the world when it comes to these rapid advances in ancient DNA testing. We also are now faced with the social applications of DNA. And one very pertinent example was one that I talked about at the weekend, and that was the mass grave at Tuam. And it's been known to exist there since the 1970s, and this is the 796 children found in a pit below the site of the former children's home, the former mother and babies home at Tuam. It was discussed in 2014 by Catherine Corliss, and the question is, are these 796 children buried in the mass grave that has been known since the 1970s, and the locals have put up a memorial garden because of that? So this was the presentation I gave on Saturday is available on YouTube. So you can see that on my YouTube channel, DNA and Family Tree Research. That one there. If you just Google YouTube and DNA and Family Tree Research, you'll find that. And how can DNA help at Tuam? Well, identification of individuals, the reunification of bones that have maybe scattered over several meters within the pit, and the discovery of trafficked children, because there has been this question raised, were some of the death certificates forged? Were some of the children in fact sold to adoptive couples in America? So if that is the case, and several people have come forward asking that question, is it the case that my sister, who is supposed to have died in Tuam, was actually adopted and she's actually alive and somewhere in America? If that's the case, all they have to do is do the Ancestry DNA test, download a copy of the results to their computer, upload those results for free to all of these websites here, Family Tree DNA, MyHeritage, Living DNA, and JED Match. And if the sister or the sibling is not found in any of those databases, then the fifth database to check out that'll be the sixth database, is 23andMe. They can test with 23andMe. And that way they actually have access to 15 million people, one of whom might be a child who was trafficked from Tuam, if trafficking indeed took place. But there are some people, like Peter Mulryan of the Tuam Home Survivors Network, is very concerned that that is the situation with his sister. So this is the sort of thing that anyone who is worried about that can actually do. And this is a social application of DNA. This is how and it's the same technique that we use with adoptees who are trying to find lost parents, lost half-siblings. In terms of identification, and this doesn't just apply to Tuam, but it applies to any situation where you find unidentified human remains. So it could be feasible to do this with anybody, a Jane Doe, a John Doe, an unidentified person that's found at the side of the road and you don't know who they are. So it has forensic applications as well. First of all, they need a tissue sample. And of course, the tissue sample that we give will be living DNA, so it'll be a cheek swab, or it'll be a sample of saliva. It might even be a blood sample if you're at the doctor and you're doing a genetic test to test for a medical condition. But with deceased people, it's usually a tooth, for example, like they did with Richard III, or the petrous bone, the petrous portion of the temporal bone, which is just that area of hard bone behind your ear. And of course, it's called petrous because it is like rock. It is the densest bone in the human body. The yield of human DNA from ancient samples is about 58% from the petrous bone compared to about 10% from any other bone in the human body. So, and this was a technique that was promoted by Professor Dan Bradley and Trinity College Dublin. And that's just where the petrous bone lies within the human skull. The second issue regarding this type of activity is the quantity and quality of the DNA extracted from the tissue sample. Now, for us, doing a cheek swab or giving a sample of saliva, some of you may have heard back from the lab saying, oh, there wasn't enough DNA in your cheek swab, please can you do it again? So that happens also with ancient DNA. You might try to get and extract DNA from a sample, but there may not be enough DNA to analyze. And that's always going to be an issue. And as one of the problems at Tuam, we don't know if we will be able to get enough DNA from the bones of these children. The second problem, of course, is that the DNA that you get from deceased people is degraded DNA. As soon as we die, our DNA starts degrading and fragmenting. And the longer it has to degrade, the more it fragments. Now, it's interesting that we're still able to get DNA if the environmental conditions are good enough. And dry, cold conditions are the best. So that's why when these archaeologists go into a cave and they find bones in the back of the cave, they've been able to extract DNA from Neanderthals from 38,000 years ago. And that's why we know whether or not we have Neanderthal DNA in our own genome today, because they've been able to sequence Neanderthal DNA from bones that were 38,000 years old. Compare that with the case of the Titanic, which only happened 100 years ago. And in 2001, they exhumed the graves of 3 unidentified people in Nova Scotia. 2 of the graves, there were no human remains left, because they had been waterlogged and the water speeded up the degradation process, so there was nothing left in those graves. There was a bone left in the 3rd grave, and they managed to get a DNA sample from that, and by doing that they were able to identify the unidentified child that had lain in that grave for 90 years. So it's environmental conditions rather than the age of the bones that is most important in terms of whether or not we can get good quality DNA from the sample. Secondly, when we go on to DNA testing, there are 3 types of DNA, Y, mitochondrial, and autosomal, as we've said. There are 2 types of DNA markers. So you can get some tests looking at STR markers, some tests looking at SNP markers, and there are 3 approaches. The forensic approach, which uses only a very small number of markers. For example, the YDNA test for forensic science is 17 markers. The one that we use in our genetic genealogy goes up to 111 STR markers or 85,000 SNP markers. So it's a magnitude greater than the forensic approach. Ancient DNA, they're currently using the whole genome sequence. So instead of doing 17 markers, they're doing 3 billion. So that's a huge order of magnitude different. And more, I think, the techniques that are being discovered by the likes of Dan Bradley and Jens Carlson and TCD and UCD, those whole genome sequence techniques will filter down to the commercial tests like Ancestry, Family Tree DNA, and also filter down to the forensic tests as well. And that means the future is going to be a very different country to where we are now. In terms of DNA for comparison, you can either use ante-mortem samples, in other words, a sample of tissue from the same person that was taken before they died. Very good case is the case of Anastasia, Princess Anastasia. They didn't know whether the person that claimed to be Princess Anastasia was an imposter or was the real princess. And after she died, 10 years or so later, they dug up the Romanov family and they were able to get an old sample of tissue from the alleged Princess Anastasia that when she had undergone surgery, they contacted the hospital, got the old sample, compared it to the Romanovs and also to Prince Philip, who is related to them, and showed that she wasn't Princess Anastasia. She was, in fact, a woman called Anna Anderson who had mental health problems and had for many, many years claimed to be Princess Anastasia. We can also target individuals like they did at Fromell and like they did with Richard III, where they looked for relatives supposed to be descended from Richard III and compared their DNA to the DNA of the skeleton in the car park in Leicester, and that proved to be a match. And they did the same thing with Fromelles, where they had 250 World War I soldiers. They contacted the families of 1,650 soldiers, got DNA samples from all of them, and compared them against the 250 soldiers they found in the mass grave. And so far, they've identified 159 of the 250 people. And then there's general populations, such as forensic databases like CODIS, or public databases like JED Match, which is the one that we use in genetic genealogy. So the last step then is to establish the identity. This will never be absolute. All we can give you is a probability. It may be as high as, well, in the case of Richard III, 99.9994% probable that it was Richard III. In the case of Thomas Kent, they came to the conclusion that the likelihood ratio was 5 trillion to 1, that he was related, that the bones they found were related to the nieces of Thomas Kent, then not. So 5 trillion to 1. So that's the kind of statistics that are needed. Very recently, 5 weeks ago, this broke in the news. And this was the case of Buckskin Girl, a murdered 21-year-old girl found in Ohio in 1981. For 37 years, they could not identify her, despite the best that forensic science could throw at the case. But it was taken on then by the DNA Doe project, which was set up by some genetic genealogists, and they managed to extract DNA from a 37-year-old blood sample from 1981 that had never been refrigerated. So they managed to get DNA from that sample, and they ran multiple profiles through the analyzer, and the long and short of it was that they were able to get between 50 and 75% of the SNP markers that were used by direct-to-consumer companies. Then a spoof kit was created by Greg Magoon, and all this meant was that they extracted the DNA markers that we use in our genetic genealogy tests. So now they had, and it was like an Excel spreadsheet, downloaded into an Excel spreadsheet just those markers that were relevant to genetic genealogy. Then they uploaded them to JED Match, and the typical kit for this Buckskin Girl was about 500 to 600,000 SNP markers out of a possible 900,000 that JED Match could deal with. Heterozygosity index was 19.5%, and the no-calls were 35%. So they got about 2/3 of the DNA and were able to extract about 50 to 75% of the relevant DNA markers for comparison with everybody in JED Match. So they uploaded it to JED Match, compared that DNA profile from Buckskin Girl against 800,000 profiles, and they got a first cousin once removed match. And they had the email address of this person from JED Match because it's public. They looked for that on Ancestry, found a corresponding tree, and within 4 hours, they opened up one of the members of the tree which said, missing, presumed dead. So after 37 years, Buckskin Girl was identified within 4 hours of the upload of her results to JED Match. And that just goes to show how powerful the combination of DNA and genealogy can be. Now, her mother was contacted because she'd never changed her address, she'd never changed her phone number, and she was always hoping that one day her girl would call her. So the take-home messages are that there have been major recent advances in DNA technology. Autosomal DNA extraction is possible from ancient samples, and sufficient SNP profiles can be generated for comparison with samples from living people, whether that is targeted relatives like Richard III and Fromelles, or with the general population like Buckskin Girl was done with JED Match. The approach is very similar to that done by the commercial direct-to-consumer companies and JED Match. You just take DNA from certainly for Tume, for example, you could take DNA from a prospective family and compare that against the entire database of DNA from the remains in the mass grave. And you just could see if there's a match, is it a first cousin match, a sibling match, that type of thing. And identification is possible. So identification of remains is possible, and it's becoming more and more possible as the technology advances. There are, of course, ethical issues, and I'll just deal with the last few slides and then throw it open for questions. Before qualifying for DNA comparison, people in relation to Tuam must have reasonable grounds to expect to be related to one of the children in the mass grave. But what are reasonable grounds, and where do we draw the line? We draw the line at first cousins, at second cousins. These are ethical questions that nobody knows the answers to at this point in time, and there needs to be discussion to see what we as a society are happy with. And then what if some family members want to do the test and other family members say, no, we don't want anybody to do the test? How do you resolve these conflicting desires? Is there a case for identifying all the children? Do all the children deserve to have their name on their gravestone? Possibly yes. Do their families deserve to have their privacy protected? Possibly yes. But how do you then balance these conflicting desires? Could the identification be done without publicity? Again, possibly yes. So there's all these possibilities, but we need to find through this array of different desires and wants, what is the path that causes the least potential for harm and the most potential for good? And that's a huge question that we're being left to answer now. So using GetMatch to identify these children, we could generate spoof kits, upload them to GetMatch, just like we did for buckskin girls, and the identity of the child could be deduced, and then a specific family could be targeted for confirmatory DNA testing. Just so you know, this is GetMatch. These are my matches here. There's the kit numbers. This is the amount of total centimorgans. These are the names and the email addresses. They are partially pseudonymized. This database is run by 2 volunteers. We also have the shared centimorgan project, which is based on 25,000 known relationships and the range of DNA shared for each of those relationships. So we get an average and then a spread on either side. So that's based on 25,000 people. It's been generated by the genetic genealogy community. We also have it made into an online tool, a DNA painter, and you can put in the amount of DNA and it'll tell you 100% probability that that's a sibling. It'll tell you 100% probability it's a nephew or a niece or maybe a grandparent or a grandchild. It'll tell you 97.5% first cousin, 2.49% one of these relationships here. So the take-home message here is that probabilities for each relationship can be calculated statistically, and that makes it even more feasible to actually identify these children, or indeed identify anybody in a mass grave situation or in an unidentified human remains situation. So DNA has certainly come a long way since 2003, and it's changed the practice of Irish genealogy. It is now really a routine tool in the toolkit for the Irish genealogist. We have established a strong global presence thanks to a huge number of Irish surname projects, also establishing the signature of some of the clans, which has really attracted a lot of people to DNA testing. There's been cross-fertilization between academia and citizen science, spurred on by events like Genetic Genealogy Ireland and also facilitated by our own ISOGG Ireland group. And then we have had academic studies like the Irish DNA Atlas, the work at the Ancient DNA Labs, which has informed the work that we do in the genetic genealogy community. And as far as the future is concerned, I think autosomal DNA projects will become much more important over the course of the next several years. The social applications of DNA and genealogy combined, that's going to mushroom. And that's going to raise a whole load of ethical dilemmas that will spark continuous discussions of the ethical issues as they arise. So, one thing is for sure, it's not going to be boring, and the future is going to be very exciting for genetics and genealogy. Thank you.
Thank you very much. That was absolutely fantastic, I gotta say.
Pleasure.
I'll be opening up the floor now for questions. Now there's plenty. A little bit of housekeeping. We do take a subscription here. I don't know if you haven't done it already. I'm not accusing anybody, but just remember it's there. And if you just signed to register, if you haven't already done so. Okay. Listen, thanks very much. That was
Pleasure.
fantastic altogether. You said it. A quick discussion I had with you about this. D'Angelo chap.
The Golden State Killer.
Golden State Killer, yeah. That's I've just started messing around with JED Match myself, and it's not for the faint-hearted.
Well, it's raised a huge number of ethical issues again, because the techniques that they used for identifying the lead suspect in the Golden State Killer case are exactly the same ones that they were using for identifying Buckskin Girl. They got hold of a DNA sample, they generated a spoof kit that they were able to upload to JED Match, and they were looking at fairly distant connections, third cousins and fourth cousins. And from what I understand, there were many hours spent building trees and seeing where did the trees intersect, and then honing in on potential suspects. And in the Golden State Killer case, he was one of them, and they followed him. And he either left McDonald's or one of these fast food places, something like that anyway, and he discarded a cup that he'd been drinking out of. And in the US, it's allowable to take somebody's cup that has been discarded. They call it discarded DNA. We don't do that over here. And they tested that discarded DNA, and it was an exact match using their forensic tests to the DNA that had been left at the murder scenes.
Yeah.
So the use of JED Match was to generate leads, just like police might do by putting leaflets through your letterbox. Were you there on the night of, and those witness boards that you see, accident on this date, were you here, please contact the police. They used JED Match to generate leads, but they didn't, it's not admissible in court because there's no chain of custody.
Right.
They cannot say for certain that this person who you match, that it's actually their DNA, because there's no chain of custody. So a point that's made by the people who have been discussing this case on the Facebook forums is that the JED Match data will not be admissible in court. It is a lead that led them to take a sample
beyond that, yeah,
from the killer directly, and that's the DNA that will be admissible in court, the one that was subjected to the forensic DNA.
It hasn't even gone to court yet, properly.
Not yet.
It's
not
just
yet.
been arraigned, yeah.
That's right.
It was on Sky the other night. They did 4 episodes to build up, but nothing about the DNA, unfortunately.
Yeah,
Yes.
yeah.
Fascinating. So we'll take questions. Got Claire?
Are there not major privacy issues coming up?
Absolutely, absolutely.
And they're going to be very difficult to kind of sort out, as it were.
Well, yes and no. I mean, there's a huge discussion going on at the moment, because when the Buckskin Girl case broke about 4 or 5 weeks ago, these type of discussions started happening. And one of the things that people said, it's only a matter of time before they'll use it for killers and rapists. And then 2 weeks later, the Golden State Killer broke. So everybody is still...
What's in the pipeline now?
Oh yes, so there's a lot of discussion. One of the points is that when people uploaded their DNA data to JED Match, they did not expect it to be used by the law enforcement agencies in the US. Now, as far as I know, it's only been used by the law enforcement agencies in the US, and US law is very different from European law and Irish law and UK law. So this whole idea of discarded DNA, for many people, is much more worrying than the actual use of JED Match. The idea that if you just throw away something and somebody can steal your rubbish and get your DNA from that, for some people that's actually more concerning than the use of JED Match. But it does have privacy issues, and one of the things that people are suggesting is that it needs to be made very, very clear that if you upload your DNA to JED Match, it is public, or rather not your DNA is public, but your matches are public. Just like that screenshot I showed you. It's not actually your DNA results that the police have access to. It's the matches that you have. So nobody will ever be able to get your DNA data. Those 3 billion letters, they won't be able to get that. But what they will be able to do is see who you match. And they might be able to deduct from that, by looking at the family trees of those matches, they might be able to find out where you sit in the larger family tree. First cousin once removed, then you're either here or you're there. So let's focus on those 2 people. So there are those privacy issues. JED Match has since, it hasn't updated its terms of service. The terms of service have always stated, once your DNA matches go public, it can be used for a variety of different applications, not just genealogical. There may be future applications that we haven't thought of. So they've said very clearly, if you're not happy with this, don't upload your data, or if you have uploaded it, delete it. So they've also made it easier for you to delete your entire profile. So there's an extra button now that you can press that just deletes everything. Some people have deleted their family tree file, the JEDcom file from JED Match, and some people have privatized their kits. So it is possible to make your kit private. You can still see all of your matches in the database, but they cannot see you. So a lot of people have privatized their data, but not taken it down from JED Match. So it'll be interesting to see, maybe in a couple of months, if the JED Match people actually do an analysis of, following the breaking news of the Golden State Killer, how many people deleted their samples, how many people privatized their samples. And but that's important to know, because different people have different levels of comfort as far as privacy is concerned. How many people are not on Facebook and will never want to be on Facebook? Okay, this says 1, 2, 3, 4. There's about 10 people who don't want to be on Facebook. Was that before or after the decision? Before? Before. So it's before the latest Facebook scandal. I always say I use Facebook a lot for genealogy, and it's great for genealogy. But I always say Facebook is a great way of keeping in touch with people that you don't want to speak to. So I have a healthy skepticism about it, and I think it is important to find your own comfort level. Having said that, when the phone book came out in 1957 or whenever it was, people were saying that's the end of privacy. That is the end of privacy. But now, some of us are in the phone book, some of us are not. We found a balance. And I'm sure we'll find a balance with this as well, both with Facebook and also with JED Match. But it is going to take a little time, and there will be teething problems along the way. There will be alarmist, knee-jerk reactions. There will be scaremongering by some people, and that will cause people to do things that they might not need to do. In the same way that GDPR is causing some people to go absolutely crazy, and some people have even, there's lots of examples, I'm sure you've heard of some of them, of people taking unusually extreme precautions to stop the possibility of being sued or being brought to court because of GDPR, who are just doing genealogy as a hobby.
Just in relation to privacy or non-privacy, my family paternal line comes from North and Mid Tipperary, and I match you on 8
centimorgans?
20 and 13 and 15 on JED Match.
Oh, right,
number
okay.
of 8.
Eight segments?
No, 2 segments.
2 segments,
Yeah.
okay. Well, hello, cousin.
Very distant.
I spin it around. Anybody else? Tom?
I'm also descended from Gleasons from North Tipperary.
Okay.
On one side. And
Congratulations.
I have not done a test. On the other side, my mother-in-law would have been a close relative of one of the families where the babies went down in the Titanic, and Rice family from Athlone.
Right.
And,
Yes, I was, when we had Genetic Genealogy Ireland Belfast, it was in the Titanic Centre, and if nobody has actually gone there, it's well worth the visit. It's a wonderful exhibit, and it's won lots of awards, and I think I saw the Rice family are actually mentioned there as well.
Oh, yeah.
Have you've been there as well?
I haven't actually been.
No, but it's got some great exhibits.
Gentleman there.
Thanks. I'm not sure that from what I've heard that you may be able to help me or advise me, but I've been at genealogy for 40 years before all this computerization and everything came in, doing the hard slog. Cost a fortune over the years.
Yes.
And time as well. But I'm skeptical about some of these ancestries and Find My Past and all of that.
Yep.
Can rip you off too. And I've a huge amount of information. I'm interested more in putting flesh on the bones.
Sure.
And I've followed particular families going back 200 years and seeing where the people went to, including a lady who was in Los Angeles before the arrival of the railway there.
Right.
And her brother, who was down in Port Elizabeth at the time of the Phoenix Park murders, where the famous Carey was arrested in Port Elizabeth. And I know all about that, but and I've got a huge amount of information, but I'd like to use, if I could, DNA just to confirm that findings I have found that I've come from the right source. Because two examples, and one I'm a little bit skeptical. My grandfather was born in Liverpool, one of my grandfathers, and he was a John Francis Mackenzie. John Francis Mackenzie. But he had an additional name in. He was John Francis MacDonagh Mackenzie. MacDonagh Mackenzie. And his father had died when he was 3. And the mother married again a John MacDonagh. And I'm wondering, was he a MacDonagh or was he a Mackenzie? The father died in Manchester, and he died of respiratory disease.
Right.
Respiratory disease. But the mother married again a MacDonagh, who I think was a best man, but I'm not sure. They were both boiler makers, boiler engineers,
Right.
linked to the B&I line and factories and all of that.
Oh,
The Industrial Revolution. So it may have been that just there was friend and he
Sure.
was given the friend, but I'd like to be able to find out. I know there's a living relative. She's not into it, but whether I could get the
few more
DNA.
people, yeah.
No, absolutely.
But
Um,
and
it's-
just without going into finding out 14,000 cousins
Sure.
and having to communicate.
Well,
the lady here.
it's actually very, very feasible to do that. And in fact, that's an excellent use of DNA, is to confirm the documentary work that you've done.
Yeah.
Because if your documentary work is correct, and this is your second cousin,
Yeah.
then the DNA will show that up.
Well, who do I go to?
What you would do is you want to have a cousin on the Mackenzie side,
Yes.
and you want to have a cousin on the MacDonagh side,
Yes,
and get them to do the DNA testing.
yes.
So that could actually help you determine.
Without going through ancestries and all of these.
Oh, yeah.
Well, you'd need to make sure that they were located in your family tree somewhere. You know, so presumably your genealogic work has identified a lot of the descendants on.
I couldn't go to a lab and say, you know, will you do my DNA, and will they get their DNA done back?
Oh yeah, no, that's what I did with my Gleasons actually, because we had a wedding memento from 1893 for this Gleason family in Australia that was in my great-grandfather's papers in Dublin. What was their wedding memento from Australia doing over here in Dublin? They were Gleasons, but we thought they weren't related to us at all. I managed to do the genealogy and trace a grandson of the person who got married. He did the DNA test, and he was a second cousin match to my father.
But you did it through DNA ancestry.
Oh, I did it through, this one I did through Family Tree DNA.
Yeah.
But you could do it through any of
Family
the
tree.
major companies, but you just get 2 relevant people from the tree who
Yeah.
should match if the tree is accurate,
Yeah.
and get them tested.
And get them tested.
Get them tested.
Yeah.
Sorry, lady there.
And I've a
I'll
separate
Sorry,
take,
can you
co-
just
talk,
ask
to,
the-
talk to me
okay.
afterwards, and I'll
Yeah.
give you some information on
Sorry,
that.
I just wanted to say, you kind of didn't ever mention the mitochondrial in the end.
That's because
And
it's the
I'm
least
just
useful.
thinking, is that something that's not as progressed as the
Right.
YDNA?
Sure, it's the least useful of the 3 tests, largely because it goes back along the mother line, and the surname changes every single generation.
Yeah, yeah.
So it's the least useful. Also, it's the DNA that mutates the least as well. So even if you have an exact match on your mitochondrial DNA with somebody else's mitochondrial DNA, the common ancestor could be 500 years ago. So I find it the least useful of the 3 types of DNA, and in terms of bang for your buck, the autosomal DNA test is the best one. And it's actually cheaper than the mitochondrial as well. So I'd only use mitochondrial in very, very specific and very rare situations. Yeah.
Sorry, gentleman up the back.
Ancestry DNA came back with, say, 95.5% Irish, Scottish, Welsh. Recently did my heritage, and that came back 100% Irish, Scottish, Welsh.
So the question is, which one is best? And my colleague Donna Rutherford has a great answer. She said, the right one is the one that best fits your preconceived ideas. And that's
Most flattering.
that's really just to say that you should only think of these ethnic estimates and these sub-regional estimates and these county estimates as broad brush strokes, okay? And there's several reasons for that. If your brother or sister did the same test, they'd get a different result. Why is that? Because you got 50% of your DNA from your father, 50% from your mother, so did your sibling, but it was a different 50%. You got chromosome 13579, they got chromosome 246810. So that's the first reason. Second reason is that the reference population varies from company to company. So, for example, the reference population in Ancestry is, I believe, 133 people. The reference population in Living DNA is actually much lower than that. It's very, very small. And their Irish estimates are way off. I did my test, I was 7% Irish, 93% British, because the British side is all done with the people of the British Isles Project. So they just match you to the nearest one to your group. And if they don't have a reference sample from your group. So I'm sure that when they do the Irish portion on Living DNA, I'll come back as 93% Irish and 7% British. So those are two major reasons for why you get these differences between companies, and it's largely the different reference data sets there.
I'm seeing some shuffling outside. I think we'll take one more question and brief, and we'll have to call it an evening at that. Anybody? Question?
Yeah, one question.
Yeah, sure.
Say I think that I have a French ancestor maybe in 1600 or 1700. If I do my DNA test, put it up on the system, will it match me up with anybody in France?
Possibly, but you have to be really careful now, because you've said 1600 to 1700. The reach of the autosomal DNA goes back to 1700, and not much further than that. So you're looking at really, really, really distant cousins at that point in time. The only other thing that you could do is do a YDNA test, which goes back 250,000 years, and you could try and research the surname and cousins who match you on that particular surname line. And that might be more suiting to your needs. But the question is then, do you actually carry that surname of interest? In other words, for me, I'm a Gleason, and my direct male line is Gleason, 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 Gleason. But I was interested in the Spearans, who were in the middle of my pedigree. So I had to go back to my great-great-great Spearan grandfather, trace all of his descendants, find a direct male line down, Spearan, 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 find a third cousin whose name was Spearan, and I said, would you please do a DNA test so I can research our Spearan line? And he agreed. So that's how I got Spearan DNA from an ancestor in the middle of my tree that wasn't on my direct male line, Gleason, 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 Gleason. So you'd have to do the same with that particular surname in your family tree. Find a cousin whom you probably never met before and ask them for their DNA.
How do you do that? That's the
With great subtlety and diplomacy.
I sent it to my brother, and and he was there saying, "Oh well, I could get it off done to some private place somewhere in some university, and might get it done there rather than put it on." And I'm thinking, forget it.
Which the thing is that, just coming back to the privacy issue, you don't have to use your own name.
That's okay.
You can use Clint Eastwood. I wouldn't use that because everybody wants to be your cousin. But, you could use a false name. And I've done it frequently with clients. The other thing you can do is use initials. And also you can privatize the kit. You can make it public until you get the information you need and then just close it down. And you can always delete your DNA at any time.
Spoof kit, is it?
No, just any kit. If you do a test with Ancestry, you can delete that as soon as you get the data you want out of it. So so with your question now, if you wanted to just prove, answer a question, and the DNA answers the question, then you just delete the DNA and that's it.
But is it not true that in about 5-6 years' time, that they'll be, they could get more and more granular? You showed a thing from Ancestry where you're into the county.
Oh yeah.
And as more and more studies will show, they'll get
more and more granular, and we'll get a lot of more information. So in that way, if you want to leave your DNA there and you're comfortable leaving it there, it can act as a legacy. It's kind of the gift that keeps on giving. When we first started, my dad did the test. He had 360 matches. He now has 11,000 matches. So do not add them to your Christmas card list. You're going to get more and more and more.
Big hand.
Thank you. Oh, I have DNA kits here. If anybody wants a DNA kit for family tree DNA, either for the YDNA or the autosomal DNA, I have a few here and I can give them to you. You can bring them home, fill out the white form with your credit card details and post it in to Family Tree DNA. The autosomal DNA test is Family Finder, which is, I think, $79, whatever that is in euro. And then the YDNA is $169. So that is just in case anybody wants to do a DNA test. I have some kits.
Just a reminder, on June the 12th, we have Declan Brady here talking about history and genealogy. You can't have one without the other. That's the next talk. If it's half as good as tonight, it'll be great. Round of applause again.
Thank you very much. Thanks very much. Thank you.
Shinabad.
Is your dad Marsden?
He is.
Did he work for CBP?
Yeah, I mean,
Packaging?
Yeah.
That's the one.